learners, I hope you are doing well. In the last video session, we did the concept of correlation, the theoretical concept of correlation. In this, we will learn about the computation of the correlation coefficient, the manual coefficient, the computation of correlation coefficient. Although there are many software like SPSS, Excel, where you can do the correlation calculations, in the software itself, but if you have to do it manually, then we will learn how to do it. So let's begin. So these are the learning objectives through this video session. We'll be learning how to compute the coefficient of correlation with the help of Pearson product moment coefficient of correlation and also with the Spearman rank order correlation. So we'll learn both. Let's start with the Pearson product moment correlation. It was developed by Carl Pearson and is denoted by the small r. It is a measure of the strength and direction of a linear association between two variables. In this last video, we had discussed about what is a linear association. It is a change, how a change in one variable is to change in the other. That's a linear association. And this ratio is basically what makes a association linear or non-linear. So we use that to calculate coefficient of correlation when the assumption of parametric statistics are met. So you need to have an understanding of what is a parametric statistics and what are the assumptions of the parametric statistics. So for Pearson product moment correlation, we need to know the assumptions first of all. We cannot use Pearson correlation in certain conditions. What are those conditions? We will see. And what are the conditions in which we can use Pearson correlation. So when your variables are in the interval or ratio scale, we say we can use the Pearson correlation. But if they are in the other scales which are not continuous like a normal or ordinal, then we cannot use Pearson correlation. When the relationship is linear, as an increase in one also leads to increase in the other, or a decrease in one leads to a decrease in other, or an increase in one leads to a decrease in the other, which is an inverse relationship. So these are linear relationships where we can use Pearson correlation. In terms of curvilinear relationships, we cannot use Pearson correlation. When your variables are normally distributed, they follow the NPC shape, then we can say that we can use Pearson correlation. If your data is skewed or any other shape, then we cannot. When there are no outliers, then we can use the Pearson correlation. We should try to avoid the outliers or the extreme scores which deviate from the other scores. Otherwise, your Pearson correlation will either be underestimated or overestimated. We also need to follow the assumption of the homoscedasticity, which is an assumption of equal variance in both the variables. Now we will learn about the computation of this correlation coefficient with two methods I will talk today. One is a deviation score method and other is a raw score method. As the name suggests, deviation is the deviation from the mean, the deviation of the score from the mean, and raw score is the original score which you get. So let's get started about the deviation score method. You can see on my screen the formula for the deviation score method. It is Rxy is equal to summation of xy divided by n into sigma x into sigma y. Now here you can see this is a formula. Summation is the sum of the deviation. There is a small x and the small y. Please be careful here. In statistics, we generally use small x and small y for deviation and the capital X and the capital Y for the raw scores. So R is a correlation here and X is a deviation of the score from the mean. So if there is a score of X, so you calculate the mean and subtract it, so you will get the deviation. Similarly, you do it for the Y variable also, and then you multiply this X and Y and find its sum. Now here sigma x is a standard deviation of the score of x and sigma y is a standard deviation of the scores in y. N is the total number of participants or the frequency. Now how do you calculate sigma? There is a formula again for it. Okay, I'll just try to highlight it. It is again you can see this is an under root. So this is a under root of summation of x square, which is your deviation square, okay, upon n. Similarly you do it for the y score, and when you substitute these values in the coefficient formula, this is what you get. So this is a summation of small x into small y upon under root of summation of small x square is and summation of y square. Okay, we will learn it through a hypothetical example. Suppose a researcher wishes to find the correlation between two variables x and y. So we have to find the correlation using the deviation score method. Now suppose this is data which you will be given. Now you have to make a table like this. Now you will only be given the score of x, this bigger x, and the score of y. This is a capital Y which is indicating the raw scores. Now these are the scores which you are getting for the x, and these are the score of the y. Now how you have to calculate the deviation? For that, first of all you have to calculate the mean. For this you have to calculate the mean. And how do you calculate the mean? You sum all the x values, summation x, which comes out to be 30 here, you can see, and then you divide it by the total number, which is the 10 participants are there. So the mean which you get is this 3. Okay, similarly you find the mean for y, which is denoted by y bar, which comes out to be 4. Now once you get the mean, you can calculate the small x and the small y value, which is a deviation from the mean. So when you subtract the x, bigger x from the mean, x minus x bar, so you will get the x, small x values and the y values. So just do it for 1. You can see the x value is 3 and the mean is also 3. So 3 minus 3 is 0, which is written here. Okay. Similarly you do it for 4, 4 minus 4, which is also 0. So first values is 0, then you do it for the 2 minus 3 for x, 2 minus 3 is minus 1. Okay, and likewise you do it for all. Now then you multiply this x and y values, so you get this table here in this xy. Okay, and finally you add this xy values, which comes out to be here as 8, you can see. So summation of x into y is 8. You also find the x square, because we have to so many times the standard deviation is not given, so we have to find the summation x square also. So when I multiply, square the x, small x values, so I get the x square, small x square values, deviation ka square, and then when I come sum it, so it is a sum of the square division, which comes out to be 10, you can see. And similarly I do it for small y. So deviation score, the sum of deviation score for y value is 8. Let's move ahead. Now when I put all these values, okay, in this formula which I have got, so for x into y I know 8, then under root of 10 into 8, finally when I calculate, I get the value of 0.89. Now 0.89 is a positive, because it's a positive sign, and a high correlation. It's actually a very high correlation, equal to almost equivalent to 0.9. So this is a deviation score method. Let's move to the raw score method now. Now raw score method, as the word suggests, we will use the original or the raw scores here. Now this seems to be slightly complicated formula, but when you do it, it is not so. So this is the formula you can see on my screen, n into summation of, now this is a capital X and Y, because these are the raw scores. So please use these terms very carefully and do not interchange with the small x and the small or the capital Y. It changes the meaning. Minus summation of x into summation of y, and then divided by the under root of n into summation x square minus summation x ka whole square. Again you can see multiplied by n summation y square minus summation y ka whole square. Please use these terms carefully. In the square, so many times students make mistakes because they they get confused in the value of summation x square and summation x ka whole square. Now you please, summation x the sum of x values, summation y is the sum of y values, summation x square is the sum of square of x values. So what you have to do, you have to square the x values first and then sum it. Same goes for summation y square, you have to square the y values first and then add it together. Okay. Instead, summation x is, you sum the x values, the x ko aapko add karna hai and then you have to square it. Likewise, you have to do it for summation y. So you add all the y values and then square it. Then summation xy is simply the sum of the product of x and y values. Now we will take another example to understand this. So you have been given this example where you have 5, I have purposefully taken 5 participants so that when you solve it, it is simpler. So I have taken 2 variables x and y and I have the scores of the participants on both n, x, y. So 4, 5, 8, 10, 12, 15, 16, 20, 10, 12 you can see. Now what I have to do, you go back to the formula and see what values you require. So you require all these values and likewise you calculate them. So we require the value of x square. Okay. So I calculate the square of all the x's. I also require summation of x values. So I have summed the values of x and it is come out to be 50. You can see here summation x is 50, summation y is 62. Okay. Then I also sum the x square values which comes out to be 580. Then I square the y values and calculate it, add it, the value is 894. Just cross check it, do it yourself. Then I also calculate x into y and again sum it to find the value to be 720. So just try doing it yourself, don't go by the values which I have given, please calculate it yourself through the raw data. Now when we put these values into the formula which I had given you, then this is how it goes. Just see, calculate it for yourself and this will be the figure, and the final correlation, if you calculate it correctly without making any calculation mistakes, would be 0.992. You can round off it to find a 0.99 is a very almost perfect correlation and a very high and positive correlation. So this is a way through which you can find the correlation coefficient through the raw score method. Okay. Now we have covered 2 methods in the Pearson correlation. Now we will see the Spearman rank order correlation. Now Spearman rank order correlation, quickly I will just have given you the assumptions of that. So it's a non-parametric measure of association between 2 variables. Okay. So when your data is in ranks, in the form of ranks or is in the ordinal scale, then you can use the Spearman rank order correlation. It is denoted by the letter rho. So when your data does not fulfill the assumption of normal probability curve also, then also you can use the Spearman correlation, and when your sample size is less than 30, so that's why it is called a non-parametric measure, then also you can use the Spearman rank order correlation. So let's see what do we do. So there are again 2 methods here of calculating it. They are same, but without tied ranks and with tied ranks. because we use ranks in the Spearman correlation. That's the first criteria. You cannot use the raw scores. Even if you have got raw scores, we have to convert it into ranks, and we will learn how to we convert it into ranks. So when we have ranks which are not overlapping, all the numbers, all the ranks are different, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, then it is called without tied ranks. But there's a possibility that two scores are same and you might have overlapping ranks. In that case, we used another formula. There's a formula is same, the method is slightly different. So we call it with tied ranks. Let's start with the without tied rank. The formula is very simple. Okay, so as a word यहाँ पे you can see it is rho. Rho का formula is 1 minus 6 summation d square upon n multiplied by n square minus 1. So what is d here? D here is the or d square is the sum of the difference squared. So what is the difference? We will see now, and n is a total number of participants. So take again hypothetical example I have taken here, and this is a raw score which have been given. Now if you have to calculate the Spearman rank order correlation, you have to first convert this raw score into rank. How do we do that? We will just see. And D also we will see, D is a difference in the ranks. So when we know how to calculate the ranks, then we can also calculate the D. Now this is the data. So you can see here I have given the lowest score as 1, but you can also give highest square as 1. It does not make a difference, although it makes more sense to give a highest score as a rank of 1. Okay. So, but in this case I have given the lowest score as 1 rank. So, in the lowest score in the X category is 8. So, I have given it the rank of 1. Then we will see which is a higher number than 8. So, we will see 10. So, 10 is higher than 8, I have given it the rank of 2. Then 12, so I have given it the rank of 3. Likewise, I have done until 7, the highest number is 40, so the highest rank is 7. Okay, so these are R1 is actually Rx, it is a ranking of the X. Now, same I have a Y score, so I give the value of I give the rank to this Y, which is R2, or you can also call it RY. So here the lowest score is 6 and the rank which I have given is 1. Then the next highest score is 8. So I have given it a rank of 2. What is the highest score? Then 8. So I can see it's 10, and then I have given it a rank of 3. Likewise, then 12, 4 and 15, 5, like that, 6, and the highest score here is 25. So the highest rank is 7. Now what do? I calculate the difference between R1 and R2. Now signs here don't matter because ultimately we have to square it. So you can do R1 minus R2 or R2 minus R1, it doesn't make much difference. So R1 minus R2 is 2 minus 5. So 2 minus 5 is minus 3. Similarly, if you see the second score, 3 minus 3, it comes out to be 0. Likewise, I do it for all, then I square it. If I sum this value, it comes out to be 0. So, that is not necessary. Now you calculate D square. So when I calculate D square, I square the D value and then total it. So in my case, it has come out to be 48. Now when I put it in the formula which I had shown you, okay, this is a formula. Now you put all these values, the formula is simple, you don't have to learn or remember much here, you just have to see there is a D thing and the N. So when I put these figures and I calculate it, so I get the figure of 0.143. 0.143. Now 0.143, first of all we can see the sign, it is a positive correlation, but at the same time it is very low. very low, because less than 0.3 it is very low correlation. So this is how you find the Spearman rank order correlation with when the ranks are not tied. Now what do we do when the ranks are tied? So here I have given you another example where you can see they are overlapping or repeated numbers. Okay, they are repeated numbers. So you can see here what is repeating. 19 has come twice. Similarly in the y values, y can see 22 is repeated twice. Now how do I go about it? So first of all I have to make the table like which I have made earlier. So I put the x values and the y values. Now here the process of giving rankings slightly changes. Let's see how. So again I start with the lowest value, so I give 12 is my lowest figure here, so I give it with the rank of 1. Okay, then after 12 there is a 16, so I give it a value of 2, fine till there here, no problem. But then I see there are 2 19s. So how do I go about it? Okay, so what do I do? In my mind I give a 3 value to this 19 and 4 value to this. You can give it to any, it doesn't matter which 19, they are equal. Now in my mind I have given 3 value to this and 4 value to the other 19. Then what do? I do a simple calculation. I add 3 plus 4 and divided it by 2. So the figure which I get is 3.5. So 3.5 is my real rank for these two scores. Okay, so I get 3.5 to 119 and 3.5 to the other 19, because the scores are equal, so the ranks also have to be equal. Okay, now next what is the figure? Next figure is what you get is 23. Now what rank I have to give to 23? Because I have already given 4 rank to this 19, so the next rank which I will give is 5. Okay, and then thereafter 24 I give a rank of 6. If they are still more overlapping or repeated number, then likewise I will do the same. For just take hypothetically, suppose this 23 was repeated again twice. So you will do again, you will give 5 rank to 123 and 6 rank to another 23, and then what you would have done? You would have done 5 plus 6 divided by 2 and it comes out to be 5.5. So you would have given 5.5 to ranking to the both the things, but here you don't need that. Okay, here you don't need that. So this is not applicable here. So I have just give you rough example that if there would have been another repeated score, then what would you have done? But in such case only one is there, so a highest ranking is 6. Similarly, please do it for the y thing also. The lowest ranking is here, the lowest raw score is 9, so first rank I have given it to 9. Then 14 is another, so I have given it to 2. Then 18, so that's a ranking of 3. Okay. Then after there is a rank of 20, there is a score of 20, so I have given the rank of 4. But then we find there are 2 equal ranks which have come, repeated scores. There are repeated scores 22 and 22. Now what do? So I have already given 4 rank to 20, so I will give 5 rank to 122 and I will give 6 rank to another 22. So I will do the same calculation which I have done. Okay, 5 plus 6 divided by 2, which comes out to be 5.5. So I have given 5.5 to both. Okay. Now already 5 and 6 have been given. So the next rank, if there would have been a higher number, now in this case there is no higher number than 22, but suppose there was a 24, so you would have given it a rank of 7. Okay, but in the present case we can see the highest ranking is 6. Now again I do the same thing, R1 minus R2, which is D. I calculate the difference, then I square the difference and I then sum the squares. The figure which I have got is 29.5, which I have highlighted, you can see. Now I will put these the figures which I have got into the formula and do the same calculation. The formula remains the same, it's just the calculation of rank differs. Okay, So the figure which I have got is 0.157, okay, 0.157, which is again a low and positive correlation, okay. So this is all about the computation of the correlation coefficient. In this session, we have covered the assumptions of the two correlation coefficient, the Pearson and the Spearman. We have also seen the computation of Pearson correlation with two methods, the deviation score method and the raw score method, and we have done the calculation of the Spearman rho through the tied rank, without tied rank and the tied rank. I hope you have understood the calculation, the computation of these correlation coefficient and enjoyed this session. Thank you so much.